Hey there, and welcome. So, have you ever found yourself staring at a statistics problem feeling completely and totally lost? Well, if you have, you're definitely in the right place. Today, we're going to tackle one of the biggest hurdles in statistics. How in the world do you choose the right hypothesis test? It's something that honestly trips up almost everyone, but we are going to make it simple.
So, does this screen give you a little anxiety? Yeah, it's that classic statistical crossroads. And let's be real, it's pretty intimidating, right? You've got your data, you've got a question you want to answer, but trying to figure out which of these formulas to use can feel like you're just guessing. But here's the thing, there's a super simple, logical way to cut through all this noise, and we're going to build that roadmap together right now.
You know, the secret to untangling all of this complexity isn't about memorizing every single formula. No way. It's all about learning to ask one simple question first. This single question is your starting point, your North Star, and it will guide you to the right path every single time.
No, really, I mean it. We're about to pull back the curtain on the one step that's like a key unlocking this entire decision-making process. Once you get this one idea, that jumble of formulas we just saw starts to look a lot less scary and a whole lot more organized.
And here it is. The single most important first step you can take is to identify the parameter. That's it. Seriously. Before you even think about numbers or sample sizes or formulas, you have to stop and ask yourself, what am I actually trying to measure? Is it a percentage? Is it an average? Or is it how spread out things are? This one question is everything.
Okay, so think of this table as our roadmap. It's that simple. At this level, there are really only three main things, three parameters we test. So if your question is about a percentage or a yes-no kind of outcome, your parameter is P for proportion, and that's going to send you to a z-test. If you're looking at an average value, your parameter is mu. That's the Greek letter mu, and that points you straight to a t-test. And if what you really care about is consistency or spread, your parameter is sigma, which leads you right to the chi-square test.
All right, so let's walk down that first path. This is your go-to when your data isn't numbers on a scale, but stuff that fits into buckets, like yes or no, pass or fail. When your question is all about the percentage of a group that has some kind of characteristic, you're on the proportion path.
So what exactly is a proportion? It sounds kind of technical, but it's really just a fancy word for a percentage or a fraction. Think about the percent of people who vote for someone, the fraction of your emails that actually get opened, or the click-through rate on a new ad. All of those, they're proportions.
Here's a perfect example from the real world. The question is about a rate, which is just a percentage. We see greater than 5%, and that's a claim about a proportion. That phrase is a massive, flashing neon sign telling us we need a test specifically for proportions. Now, before you can just jump in and use this tool, there are a few, let's call them rules of the road, you gotta check. For a z-test to work properly, you need a pretty large sample, so the math works out nicely. That sample also has to be random to make sure it's not biased. And as a general rule, your sample shouldn't be a huge chunk, like more than 5% of the entire population you're studying.
Okay, and here's the formula itself. Now, don't let the symbol scare you. You're probably never going to calculate this by hand. All this thing is really doing is asking one question. Is the result we got in our sample just a random fluke, or is it actually something surprising? It just compares what you found to what was claimed and tells you if that difference is a big deal or not.
All right, path number 2. Let's keep moving. So what if your data isn't about categories, but actual measurements? Things like height, weight, temperature, or time. Well, when your question is about the average value of something, you're heading down the path for testing a mean.
And the mean, well, that's just the average. We use this concept all the time without even thinking about it. The average score on an exam, the average time it takes to get to work, the average price of a cup of coffee. These are all means.
So check out this question. The magic word here, average. The second you see that, a little light bulb should go off in your head. We're measuring the shipping time for a bunch of packages, and we want to know about the average. The claim is that it's less than 3 business days. Boom. That tells us our parameter is the mean, mu.
The rules for a t-test are a little different, a bit more flexible in some ways. Your data should ideally follow a nice bell-shaped curve, but if it doesn't, a large enough sample size, and 30 is a great rule of thumb, can often save the day. You also just want to make sure you don't have any crazy extreme data points that are throwing off your average.
And look, the t-test formula looks pretty similar to the z-test, doesn't it? It's doing basically the same job. It compares the average from our sample to the average that was claimed and tells us if the difference is big enough to matter. It's the perfect tool for the job when you're working with averages.
Okay, time for our third and final path.
And this one's a little different. See, sometimes you don't really care about the average. What you care about is consistency. Are your results all tightly packed together, or are they all over the map? When that's your question, you need to test the standard deviation.
So what in the world is standard deviation? The easiest way to think about it is just consistency. A really small standard deviation means all your data points are super close to the average. It's a very consistent process. A big standard deviation means the data is spread out everywhere. It's inconsistent. It's like the difference between a high-precision machine and a rusty old one. In this cereal box example, it's perfect. A cereal company doesn't just want the average box to have the right weight, they need every box to be really, really close to that weight. They need high consistency. So the question here is literally about the standard deviation, which makes it totally obvious which path we're taking.
Okay, big warning sign on this path. It has one really, really strict rule. The data you're using absolutely must come from a population that has a normal, bell-shaped distribution. This test is a real stickler for this rule, much more so than the t-test, so you've got to be extra careful here.
And this is the special tool for the job, the chi-square test. Its whole mission in life is to ignore the average and just focus on the spread. It basically compares the amount of variation you've found in your sample to the amount of variation that's allowed or claimed, and it tells you if your process is as consistent as it needs to be.
All right, let's pull it all together. Think of what we've built as your new statistical compass, a simple tool that's always going to point you in the right direction.
So here it is, your simple 4-step framework. You're not lost anymore. Step 1, always start by asking, what am I really measuring here? A percentage, an average, or the spread? Step 2, your answer to that question immediately points you down one of the 3 paths, to the z-test, t-test, or chi-square test. Step 3, do a quick check on the rules of the road for that specific path. And boom, step 4, you've done it. You've confidently picked the right tool for the job.
Look, if there's just one thing you remember from all this, please let it be this. Real power in statistics doesn't come from memorizing a bunch of formulas. It comes from having the clarity to know which question you need to ask first.
So, there you have it. You now have the framework to actually take an idea, a claim, or a question and test it with real data. So I'll leave you with this. What are you curious about? Is that new workout plan actually more effective? Is a new ad campaign really hitting its target? The tools are in your hands now. What will you go investigate?